In the next several minutes, we will demonstrate simulation technologies that enable full product simulation by combining 3D physics with system-level analysis. The example is a washing machine that was created by ANSYS channel partner SIS in Brazil. Electric motors, drive circuits, embedded software control, thermal issues, structural analysis, and acoustic noise prediction will be highlighted. We first consider the power supply in the ANSYS Simplorer system simulation. The power is supplied to the IGBT inverter modules and the controller. The power from the network powers the printed circuit board, including an AC-DC converter, the controller, and an IGBT-based inverter. The variable speed motor is controlled by an electric drive, in this case utilizing a controller with embedded code generated by the ANSYS Esterol SCADA suite. Simplorer uses the embedded code to produce a pulse width modulated signal to control the motor speed. Here's the time domain output for one of the drive waveforms, along with the electromagnetic simulation of the currents flowing in the cabling from the printed circuit board to the electric motor. We use these waveforms in the electromagnetic simulation of the motor. We now turn our attention to the electric motor simulation using the ANSYS Maxwell 3D Field Solver. Maxwell can use the true pulse width modulated waveforms from the Simplorer as an input when it performs the 3D physics simulation. 3D electromagnetic simulations are used to generate high-fidelity reduced order models, creating a powerful electromagnetic space design flow that combines complex circuits with physics-accurate component models. This completes the primary workflow for the motors with embedded drive for a variable speed motor system. We now turn our attention to an even more comprehensive solution that brings in thermal and mechanical dynamics. The performance of the IGBT devices is temperature dependent, and accurate prediction of the semiconductor operating temperature is important for system performance. Multi-domain, multi-physics simulation is accomplished by adding ANSYS IcePack simulation to calculate the temperature of the IGBTs based upon the power delivered. IcePack relies on the ANSYS Fluent Computational Fluid Dynamics Solver to calculate the temperature on the PCB surface and the IGBT devices. Simplorer produces a reduced order model based on the IcePack simulation to solve for electrical and thermal values simultaneously. The Simplorer ROM allows Simplorer to run very rapid simulations while including the 3D physics rigor and computational fluid dynamics. Temperature feedback is used to correctly predict the real performance of the IGBTs. The electric drive controls the speed of the motor, so motor position and speed is fed back to the controller for full closed-loop control. As we have seen, the dynamics of the motor depend upon the power supply, the controller, the temperature-dependent IGBT semiconductors, and the 3D physics of the motor itself. Simplorer can now provide position, speed, and accelerations as input to the rigid body dynamics simulation of the 3D mechanics of the washing machine. Rigid body dynamics analysis predicts the stresses and transient behavior of the complex 3D structure encountered during washing machine operation based upon the input forces and torques from the electric motor. The final analysis we will demonstrate is vibroacoustic noise of the electric motor. Electromagnetic forces on the motor stator are computed by Maxwell. The result is a collection of radial and tangential forces that can deflect the stator and cause harmonic motion that induces the acoustic noise. We convert transient time domain stresses into a frequency domain spectrum, which in turn is transferred to ANSYS Mechanical for harmonic analysis. These steps are completely automated. Here you see the stator deformation based upon the forces calculated by Maxwell with Mechanical. The deformation is amplified to help visualize the effect. It is this deformation that becomes the source of the acoustic noise. Deformation velocities are used in the vibroacoustic analysis. Pressure fields and radiated far-field sound pressure levels are predicted, allowing the engineers to take measures to control generated noise of the machine. In this example, we demonstrated full product simulation that combines 3D physics simulation with system analysis. ANSYS Simplore is used to bring together numerous technologies, including Maxwell, SCADE Suite, IcePack, mechanical, and rigid body dynamics.